Are you able to see the screen? You can unmute and let me know.
Yes, sir. Screen is
Yeah,
visible.
yeah. Thank you for that. Right. So, welcome to the virtual internship training on design of foundations using the CSI Safe software as well as the manual design of footings or manual design of foundation. Myself, Castro Kiran. So here we'll be talking about how to do the design of foundations over a period of time based on manual calculations, based on Excel calculation, and also based on the software, which is CSI Safe software. So here, before I talk about what are the things that we are going to do, I would like to give a couple of instructions that need to be followed every day throughout this entire internship training. The first thing is try to make sure at least to join before 10 minutes so that it helps me to analyze like what are the problems that you are facing with, or we can also use these initial 10 minutes, we can use it for the doubt clarifications also. So in any ways, this is possible. So try to join at least 10 minutes before so that you can also have any kind of discussions with me, or we can avoid any kind of disturbances that gets created after the session gets started. And the second instruction is try to sit in a peaceful environment where you can clearly listen to the classes so that no other disturbances can disturb you from the classes or divert you from the classes. And the third thing is kindly be on mute. If you have any doubts, yes, you can unmute and ask the doubts at any point of time. But make sure if you don't have any kind of doubts, please be in mute position so that the class will go in a peaceful way. The fourth instruction is try to make a note of whatever the important things that you feel. So I don't tell like this is an important one, you should write a note on this one. So whichever things that you feel like it is necessary for you to write a note, so you try to maintain one particular note for the classes that happens. Okay, here and there I'll be talking about some IS code provision, some important detailing with respect to the real-time scenarios. So how we are going to take the data from the real-time industry or real-time design application. So all these things I'll be talking about here and there. So those points you can make a note of them. And then whatever the doubts that you have, as I was mentioning earlier, you can always mute at any point of time, and then I'll get to your doubts. So mostly I would prefer you to ask the doubts at the end of the session. So the last 10 or 15 minutes after the class gets completed, we'll use it only for the doubt clarifications. But if you think like you will forget to ask the doubt, you just try to make a note of your doubt so that I'll come back to your doubt at the end of your session. Okay, that's the next one. And the final one is whatever the recorded sessions that are going to happen, all the recorded sessions will be shared along with you in a private mode to your email ID. So you have registered with your email ID, right? So to all your email IDs, the all the recorded sessions of all the days will be shared with you. Okay, that's for sure. So recorded videos, you can use it for the future purposes when you are doing any kind of mini project or major project in your college, or whenever you are doing practice on CSI Safe software, these recorded videos will help you better. So here, technically speaking, you don't need to write everything that I do it in the practical classes, that is with the CSI Safe software classes. I'll provide you all the kind of material, whatever is required for you. So whatever I'm discussing in the sessions, all kinds of materials, starting from the design to starting from the Excel calculations and to the final CSI Safe design, everything will be provided to you as a material itself. So you can refer those materials at any point of time, and you can also execute those materials as your practice sessions as well. So these are the couple of instructions that I would like to give. And then this entire internship training has been divided into 4 different modules. In the first module, we are going to talk about a manual design of footings along with a brief introduction towards the design of foundations. That's the first thing that we are going to do. And in the second module, what we are going to do is we are going to prepare the same design of footings by using the CSI Safe software. Okay, we'll whatever the design of footings that we have done in the module 1. So we'll be designing 5 different types of footings, starting from isolated footings to strap footing. So all the 5 designs of footings, whatever we cover in the manual design, the same thing we are going to cover in the CSI Safe software. That's the second module. And in the third module, we are going to discuss about how to prepare an Excel sheet in order to design the foundations. So I have some predefined Excel sheets which I have prepared it over a period of time for the previous batches. So I'll also share you those Excel sheets as well. So you don't need to separately design those Excel sheets. But what I will let you know in module 3 is I'll show you what are the things or how you have to interpret the data with respect to the Excel sheets. That's the third module. And in the fourth module, we are going to talk about the validation of results. Whatever the results that we are going to get from module 1, that is from manual design and software design and the Excel sheet design. So how to interpret the data? Suppose, let's say, whenever you are in general, suppose when you are doing a manual design of, let's say, a footing, a simple isolated footing. Now, when you do the manual design, you will get some kind of details. Like, let's say maximum moment will be something like 110 kilonewton meter, and then one way shear will be some value, two-way shear will be some value. But when you do the same design in the CSI safe software, you may not get the exact results. And similarly, when you do the same inputs or when you give the same inputs in the Excel sheets, you may not get the same results. That's because of some minor errors will be there. That's quite obvious. But how to validate them? That we are going to discuss in the fourth module. So the validation of results. So here what I'll be talking is module 2, 3, and 4, I'll be covering side by side. Like we don't have a separate module for module 2 discussion, module 3 discussion, module 4. So modules 2, 3, and 4 will happen side by side or parallelly. But first we'll start with manual design of footings, which is module 1. So module 1, we are going to talk about how to do the manual design of different types of footings. Exactly 5 different types of footings. These are the 4 different modules that we are going to cover. Along with these 4 different modules, there is one bonus module that we have introduced because some of the students have asked that please let us know how to do the mixed design of concrete. So we have added that as a bonus module where we are going to talk about how to do the mixed design of concrete as per the latest version of the IS code, which is IS 10262 2019. So in the bonus module, what we are going to cover is we are going to let you know how to do the mixed design for two different grades of concrete. One is for high strength concrete and the second one is for the normal strength concrete. So that's what we are going to discuss. So this is the entire curriculum of our internship training for the next 25 to 30 days. So the internship will go for roughly 25 to 30 days. It may not be exactly 30 days. So if possible, I mean, like if things goes in the other way, it might go more than 30 days and it might come less than 30 days also, but it will nowhere. We are not going to skip any of these modules. Okay, everything will be discussed. Whatever the things that we are going to see here, everything will be discussed in the duration or in the stipulated duration of time. And as I was mentioning earlier, all your doubts, all the materials will also be provided for you. And coming to the CSI Safe software, I'll be providing you one recorded video because in order to install the CSI Safe software, you should not have the internet connection. So since I cannot give you the live demonstration, what I have done is I have made one recorded session. So you can watch that recorded video and follow the instructions that are available in the recorded video so that you can install the software as well on your own. So you don't need to install the software immediately. That is for tomorrow's class or day after tomorrow's class. This entire week we'll be focusing on the manual design of footings only. So take this entire week time and try to install it by next Monday so that next Monday we are going to start the CSI Safe software design calculations. So till then you have the time of 6 to 7 days. So take your own time. And if you get any doubts while installing the software, please feel free to ping me either on WhatsApp group directly, or you can also ping me personally as well in the WhatsApp. Okay. And the software also I'll be providing you. So I'll share you one Google Drive link by after this session gets completed. So you can download the software from that Google Drive link and then you can install the software by seeing the recorded video. Okay, but one instruction that needs to be done with before installing the software is the first thing is you have to turn off your internet connection. So make sure your laptop should not have the Wi-Fi connection on. So you try to turn off it. And the second thing is if you have any antivirus software that is available in your laptop, you have to turn off the antivirus software also. So without doing these two things, please don't proceed for the installation of the software. It's not possible. I mean, the software will not get installed if you have any one of these two things. So first thing is you have to turn off your Wi-Fi connection, and the second thing is you have to turn off your antivirus while installing the software. After installing the software, you can turn on both the things, the antivirus as well as the internet connection, right? So these are the four modules along with the bonus module that we are going to discuss. So in the first module, what we are going to discuss is we'll be talking about how to do the manual design of footings. So before we talk about how to do the manual design of footings, let us first understand what is a foundation and what is a footing. So what's the difference between these two? So before going to that, let me give you the contents that we are going to discuss here in the module one. So initially we'll start with the introduction towards the foundations and introduction towards the footings. We'll see the basic definitions of footings and foundations as well as the different types of foundations, the different shapes of foundations. So all these things we'll be covering in the introductory session. And then we'll be talking about how to do the design of a footings or design of foundations, you can say. So I'll be talking about what are the different IS codes that we are going to use, what kind of thumb rules that need to be understood. So all these things we'll discuss in the second part of this section. And then we'll be doing the manual design of footings. That is five different types of footings we are going to design. The first one is the square footing. The second one is the rectangular footing. And the third one is sloped footing. The fourth one is combined footing. And the last one is strap footing. So these are the five different types of footings that we are going to cover both in the manual cases as well as in the software cases. And I will give you the Excel sheets for the design of all these five different types of footings also. So these are the five different types of footings that we are going to focus in this entire training session. So these are the things that we are going to discuss. So now first, let us understand what do we mean by foundation. So, do you think that the foundation and footing are same? No, they are obviously not same. Actually, by definition, foundation is defined in a different way, and footing is defined in a different way. So, we'll first talk about foundations, and then I'll take you to the footings definition. So, what is a foundation? So, suppose usually when you see any concrete structure or any structure that we are going to build, the first thing that we do is we need to lay the foundation. So it is called as a substructure. So for any structure or for if you take a structure, we have two different parts. One is called as substructure and the second one is called as superstructure. Substructure is the one which is constructed below the earth or below the or certain depth below the earth surface. That's called as substructure. Superstructure is something which is constructed above the earth surface. So the only component that is available in the substructure part is the foundation. Okay, foundation is something which is constructed in the substructure part of the soil or substructure part of the structure. So substructure is nothing but the structure which is constructed beneath the earth surface. So here you can see there is the earth surface that is available here. They digged the earth surface and after digging the earth surface, they have constructed the foundation. So this is actually the foundation. This is what we are going to focus in our training also. So how to decide the type of foundation, how to decide the type of footing, how to decide the depth of the foundation, width of the foundation, all these things we'll be talking about. So in a simple definition, foundation is a part of the substructure of a major structure or substructure of a main structure. So for any structure, we have two parts. One is called a substructure and the second one is called a superstructure. So foundation is something which comes under the category of the substructure. Okay, foundation is something which comes under the category of substructure. Now, let us understand the basic definition of foundation first. So foundation can be defined as the lowest portion of a structure which transfers the load into the supporting soil. Suppose if you observe this particular figure, here there is a foundation and there is a soil. So what is the purpose of constructing the foundation? The purpose of constructing the foundation is not to carry the load. Okay, we are not designing the foundations or we are not designing the footings to carry the load. What is the purpose of constructing the foundations or footings? The purpose of constructing the foundations or footings is to distribute the load to the soil. So whatever the soil that is available underneath the foundation, in order to distribute the load that is coming from the superstructure into the soil mass. So that's the major idea of constructing the foundation. So usually people often get confused that foundation is meant to carry the load. No, it is not meant to carry the load. It is meant to transfer the load that is coming from the superstructure to the subsoil, okay, or to the supporting soil, you can say. So that's the typical definition of foundation. Now, the main purpose of foundation, as I was mentioning earlier, is to distribute the total weight of the superstructure. Okay, whatever the load that is coming from slabs, beams, columns, all these loads has to be get distributed evenly to the foundation, and from the foundation the load will finally get distributed to the soil surface. Suppose, let's assume that you have a foundation here. Let me have some foundation here. Let's say this is the foundation. Okay, you have the column and then you have the foundation slab. So this portion is called as a foundation slab, and this is the column. Okay, you can say this, you can consider this as the column, the vertical one as the column. Now from the column we have the loads that is coming from. So how the load distribution will happen in a structure? So first the loads will act on the slabs, then from slabs the loads will get distributed to the beams, from beams the loads will be getting distributed to the columns. Now what columns has to do? Whatever the loads that is coming from slabs and beams, these loads are getting transferred to the columns. Now once these loads are transferred to the columns, this load from the column has to be distributed to the footings. Okay, this load from the columns has to be distributed to the footings. Now consider this case here. Now here from column I am getting some load. Let's say, let us consider that load as a P kilonewtons or P newtons. So some amount of load is coming onto the footing from the columns. Now footing will have some amount of load. Okay, whatever the load that is coming from the superstructure, all that load will be available on the footing. Now what footing has to do? It should keep the loads on it. No, it should not be in that way. Why? Because if the footing bears the entire amount of loads that are coming from the superstructure, then at one particular point of time the footing will get failed or the foundation will get failed. Now, what is the purpose of providing the foundation or footing? The purpose of providing the foundation or footing is, so below the footing or below the foundation slab, you have the soil mass. Let us consider this as the soil mass. Okay, exactly under the foundation or foundation slab, you have the soil that is available. Now, whatever the load that is coming from the footings or whatever the load that is coming from the superstructure, all that load has to be evenly distributed to the soil, subsoil. Okay, that's the entire purpose of constructing a foundation or designing a foundation. Even when we are designing the foundation in the manual calculation as well as in the CSI safe software, we are going to design the foundation not to carry the load, but to distribute the load. That's the whole purpose of constructing any structure, any structural element, not just the foundation. Even if you take slabs, beams, columns, and footings, you don't design the slabs or you don't design the beams or you don't design the columns to carry the load. You will design the members to distribute the loads equally to the next layer of the structural element. Okay, so that's the typical definition or typical purpose of the foundation. Now foundations are basically the essential components which provides stability to the structure. Okay, if your structure is stable, suppose let's say you might be sitting in one room or you might be sitting in your own houses. Now if your house is safe or if your house is not facing any kind of settlements or any kind of uneven settlements or equal settlements, whatever that is, if you don't see any kind of disturbance in your structure or in the structure wherever you are sitting right now, it is all because of the equal distribution of loads. So when the loads are getting distributed in an uniform way, then there won't be any kind of problem to your structure. Whenever the loads don't distribute uniformly, then comes the problem to your structure. Suppose let us consider this one by taking a simple example. Let me take a simple beam. Okay, here let's say that there is a simple beam that is available. Let us consider it as a simply supported beam. Okay, I'll just make it as two supports here. But now let's assume that if the load is falling exactly at the center. Okay, if the load is falling exactly at the center, then the load which is coming from the top of the beam will get equally distributed to this column or to this beam and also to this beam or to the column, whatever the component is. Now here what is happening, the load is getting equally distributed. Now let us consider another scenario. Let me take one more beam. Now let's say that the load or point load or whatever the type of load P is acting not at the center. It is acting somewhere close to one of the supports. So this is one support and this is another support. So since this load is acting close to this support called A, what will happen to the support A? Support A will face huge amounts of stresses. Okay, whatever the load that is coming from this point, since it is very close to the support A will face huge amounts of stresses. Now, when huge amount of stresses are coming to the support, what will happen to the support? Till it reaches the limit state, it is fine. It will be carrying the load. But once after the limit state gets crossed, then what will happen? The cracks will get initiated in the structural element. Once the cracks gets initiated, then over a period of time, the structure gets failed. So that is what happens when the load distribution don't happen evenly. So in order to construct the foundations, the purpose is to distribute the loads evenly. Now you might have a question here. So in the real time scenarios, do we have the loads that are acting only at the center of the beam or only at the center of the foundation? No, we don't. We cannot necessarily tell that all the loads on a structure will act exactly at the center of the member. So some loads will act at the corners or near to the face of the structural member. Some loads will act exactly at the center. So it depends. Now, how will you ensure the distribution of loads when the loads are acting at an eccentricity? So we have this concept called eccentricity, which is represented with small e. So when the loads are acting at a distance e, so how will we ensure the distribution of loads? So that we are going to design, or that we are going to see in the manual design as well as in the software design as also. I'll be talking about this particular point in the manual designs and Excel, I mean, in the software design calculation. There I can show you in a better visualized way. But remember that the loads will not need not to be acted exactly at the center of the structural members. So some structural members will face an eccentric loading. Okay, that's why we have the different types of beams as single reinforced beam, double reinforced beam, based upon the type of load that is coming, based upon the type of stresses that the beam is enforcing to. And then we have the uniaxial column, biaxial column. So all these things are coming because of the point of application of loads. Although they have different purposes, but point of application of loads is also one of the considerable factors here, right? Right. So the first essential component in order to design the foundation is to give the stability to the structure. So whatever the structure that you are designing, if you are getting stability to the structure, then as a structural design engineer or as a structural engineer, you have achieved the purpose of constructing the structure. So if the structures are not stable, then there is no point in designing the foundations or designing the entire structure itself. That's one thing. And the second thing to design the foundation is, apart from the stability, we should also ensure the secure base for a structure. So what is meant by base for a structure? Now suppose, let's say you have a column, and for every column we have an footing or we have a foundation slab. So this is called as a secure base. Okay, this portion is called as secure base. Why it is called as secure base? Because whatever the load that is coming from the superstructure to the column, this column will distribute the load equally to the entire footing. Okay, this column will distribute the load equally to the entire footing. Now what will this footing will do? This footing will distribute the load to the subsoil. That's called a secure base. Now here, the subsoil which is available here, okay, below the foundation, whatever the subsoil that is available here, if this soil is weak, let's say we have a black soil, or let's say we have a clayey soil. Now what will happen when you construct a structure in a clayey soil? Settlements will happen. Now how will you enforce the settlements, or how will you ensure that settlements do not happen? So you have to go with the different types of foundations. We have raft foundation or mat foundation. So based upon the safe bearing capacity of the soil. So you all must have heard the term called SBC of soil when you are designing the reinforced concrete structures. So whenever you design the reinforced concrete structures, especially the foundations, we are going to consider the SBC of soil, which is called as safe bearing capacity of the soil. Now, how will you get the safe bearing capacity of the soil? So, geotechnical engineer will give you the SPC value of a soil for your structure or for your site wherever you are constructing. So, it is important to do the geotechnical investigations as well, or you can also call it as a soil report investigation, or sometimes you can just call it a soil report also. So, what will be there inside the soil report? You will be able to find out the SPC of soil. Okay, we have different methods to determine the SPC of soil. So you all must have gone through those methods in your geotechnical engineering or soil mechanics subject. So I'll not be going into the details of that. But here, what we are discussing is we'll be discussing the design of foundation in respect of the structural engineering field, not with respect to the geotechnical field, in respect of the structural engineering field. But again, it's important to have a knowledge on soil mechanics as well when you are designing the foundations. It's not that you don't need the geotechnical engineering. We need geotechnical engineering as well. Okay, right. So that's the these are the two essential components. One is to give the stability to the structure, and the second one is to provide the secure base for the structure or secure base for the superstructure. And the next thing is whatever the type of foundation that you are going to construct, it depends on multiple factors. Okay, the first type of factor is it depends on the soil type. So you, suppose let's say if you have black soil, what type of foundation is suitable? If you have red soil, what type of foundation is suitable? If you have the rocky strata, then what type of foundation is suitable? So based upon the type of soil that is available underneath our site area, so based on that, the type of foundation has to be chosen. So I'll be talking about which type of foundation has to be chosen for which scenario from the next classes onwards. Once we start discussing about the design of different types of footings, I'll be letting you know that. So the first criteria is the soil type, and the second one is what is the size of the building. Suppose, let's say you are constructing a 10-floor building, and in the second case, you are constructing some 20-floor building. In the third case, you are constructing just G+2 building. So based upon the size of the building, also the type of foundation will get changed, and also based on the type of building as well. Suppose, let's say you are constructing a hospital. Now, we can expect that in a hospital, 24 by 7, the people will be there. That means huge amounts of live loads will come into picture. So, when there is a huge amount of live loads that are coming throughout the day, then you need to go for a different type of foundation. So, based upon the type of building and also the size of building, the type of foundation will be decided. Okay, based on the type and size of the building, the foundation has to be decided. I'll be talking about these details very soon. And then the next one is the environmental conditions. Now, what do I mean by environmental conditions? So one is with respect to the earthquake loads, and the second one is with respect to the wind loads. Suppose, let's say you are constructing the structures in the countries called Japan. So Japan is something which is mostly experienced to the seismic activity. That is huge. I mean, every now and then Japan experiences the earthquakes. Now, in such regions, you cannot go for isolated footings. In such regions, you cannot go for combined footings. So, in some cases, we have to go for the raft foundation, even though the soil or SBC of the soil is very good, or even though the soil type is of very good soil. In such cases, we have to go for the raft or mat foundations. So, based upon the environmental conditions such as the seismic activity and also the wind loads that are coming onto the structure, we have to decide the type of foundation. Now, here you might have a question: how does wind loads plays an important role in deciding the type of foundation? Suppose, let's say you are constructing the structures somewhere like Qatar or somewhere like Dubai kind of region or Arab countries. Now, in Arab countries, we know that huge amount of wind forces will come. When there is huge amount of wind forces, especially when you are constructing the tall structures such as Burj Khalifa or the multi-scale tall buildings or tall structures, huge amounts of winds will be there on the top surfaces of the or on the top floors of a building. Now, when there are huge amount of loads that are acting on the top surfaces or top floors of a building, then you have to consider the wind load as well. Okay, these are the two cases where environmental conditions will come into picture. So, but when you are constructing the structures in any other places apart from these two things, you don't need to bother much about the seismic activity and wind loads, especially when it comes to the South Indian part. So you don't need to bother much about the seismic activity or the wind load part also. Okay, so we don't have that huge amount of wind loads that will come to the South Indian region, even the North Indian, some parts of North Indian region also. But coming to the seismic activity, some parts of North India, let's say Delhi or near to the regions of Punjab, Delhi, this zone will experience now and then they will experience some kind of seismic activity, maybe Richter scale 4, Richter scale 5 types of 5 on a scale of 5, you're going to get the seismic activity. So in some such conditions, you have to definitely consider the seismic activity in that particular region before deciding the type of foundation. So these are the basic details that need to be understood before designing the foundations and footings. Now let us understand what is the difference between a foundation and a footing. So as I was mentioning at the beginning of the session, foundation and footing, they are not same. So it depends. By definition, foundation is defined in a different way and footing is defined in a different way. Let us see that. So foundation is basically a part of a structure. This is important. So foundation is the part of a structure that transfers the load from superstructure to the ground surface. So what is meant by foundation? Suppose if you have a column which is attached with the foundation slab, so the foundation is something which transfers the load, whatever the load that is coming from the foundation slab, it is going to transfer the load to the subsoil. Okay, it is going to transfer the load to the subsoil. Then a footing is a one which is a part of the foundation. Okay, footing is the part of a foundation that is in direct contact with the ground surface. So here, which is in direct contact with the ground surface, is it the column or is it this slab? So this portion of the slab is in direct contact with the soil, or even you can say this entire portion is the one which is in direct contact with the soil. So this particular portion is called as the footing. Okay, this particular portion, only the rectangular portion. Suppose if you consider here, so just give me a second, I'll just draw it properly. Right. So suppose if you are constructing a foundation, suppose just consider this as a rectangle. So this portion is called as footing. So we have isolated footing, combined footing, all these things. Now, when you attach a column to this foundation, to this footing, this entire member is called as foundation. Okay, individually we can call this as the footing, and a footing which is attached to the column is called as foundation. That's the typical definition of a foundation and footing. So foundation is a part of a structure that is meant to transfer the load from superstructure to the ground surface, whereas footing is a part of the foundation. Okay, footing is a part of the foundation that is in direct contact with the ground, and hence it distributes the load from superstructure to the surface or the subsoil over a larger area. But the intention of designing the foundation or the intention of designing the footing is same, which is the distribution of loads, the transfer, getting the loads from the superstructure and then distributing the loads to the subsoil. That's the entire idea of designing the foundation or footing. Okay, so if you want to tell it in a different way, in other words, a foundation is the overall structure that supports an entire building, while a footing is a specific part of foundation that helps to distribute the load from the superstructure. I was just telling that definition now. So a footing is a part of the foundation. Okay, if you take this entire element, so this is the part of the foundation. This rectangular slab is the part of the foundation, which is called as footing. So this entire portion which is attached with the column is called as foundation. That's the typical difference between a foundation and a footing. Let me tell that in a much different way. So here, by definition, footing can be defined as the part of a structure that transfers the load from superstructure to the ground, whereas the footing is a part of the foundation that is in direct contact with the ground. Okay, the footing is one which is in direct contact with the ground and helps it to distribute the load from the superstructure over a larger area, that is the subsoil. And where the foundation will be there, the foundation will be there below the superstructure, whereas footing will be there below the foundation wall or a column. Okay, we have the foundation walls. I'll show you that images in some time. So below the foundation walls, the footings will be there. Okay, and then the purpose of designing the foundation is to support the superstructure. Okay, that's the only purpose of constructing the foundation. Why we need to provide the support to the superstructure? In order to avoid the sinking of the support, sinking or settlement, you can say. Whereas the footing is to distribute the load from the superstructure over a larger area, and then it is going to prevent the foundation from sinking into the ground. Okay, so here foundation helps to not sink the entire structure. Footing helps to not sink the only the foundation. Okay, the purpose of footing is to ensure the safety of the foundation. The purpose of foundation is to ensure the safety of the structure. That's the difference. So there is a very small difference between these two. The purpose of foundation is to ensure the safety of the structure itself, whereas the purpose of footing is to ensure the safety of the foundation. So that's the purpose of foundation and footing. So in foundations we have different types, and in footings also we have different types. I'll be talking about those differences in some time. So now let us understand what are the different types of foundations and different types of footings that we have. So foundation systems are broadly classified into two categories. The first one is called as the shallow foundations, and the second one is called as deep foundations. So these are the two major categories of foundations: shallow foundations and deep foundations. Suppose let's consider I have a foundation which is with the column. Okay, this is the column. The vertical member is the column, and this is the foundation or footing, you can say. Okay, so now for any foundation, we have two important elements. One is called as the width of the foundation, that is called as BF. You can see here BF represents width of the foundation, and the second one is called as the depth of the foundation. Okay, width of the foundation and depth of the foundation. So here depth of the foundation is something which is considered below the ground level. If you consider this as the ground level, so below the ground level up to the surface or up to the bottom surface of the footing, whatever the depth that is there, that depth is called as depth of foundation. In simple terms, you can represent with capital D, or sometimes people also represent with D suffix F, something like this. Okay, D suffix F, depth of foundation. Anything is okay. Okay, so these are the two important dimensions that need to be evaluated before designing the foundation or footing. So one is called as width of the foundation, and second one is called as depth of the foundation. Now the question is, when we call a foundation as a shallow foundation and when we call a foundation as a deep foundation, what's the difference? Or when do we call a foundation as a shallow foundation? So it depends on these two dimensions, BF and D. When the value of BF is greater than D, then it is called as a shallow foundation. Okay, when the width of the foundation is greater than the depth of the foundation, then it is called as a shallow foundation. Now, in shallow foundation, we have different types. The first one is called as isolated footings. Okay, the first one is called as isolated footing. I'll show you the images of these ones, but let us just understand the types first. So the first one is called as isolated footings. The second one is called as wall footings. The third one is called as combined footings. And the fourth one is called as cantilever footings, or also called as strap footings. And the last one is called as raft or mat foundation. So these are the five different types of footings that are available under the category of shallow foundations. And then comes the deep foundations. So when do we call a foundation as a deep foundation? When the value of BF is less than D, then it is called as a deep foundation. That is, width of the foundation is less than the overall depth of the foundation. Then in such cases, we'll call it as a deep foundations. So in deep foundations, majorly we have two categories. One is called as pile foundations, and the second one is called as pier foundations or caisson foundations. I'll show you the images so that you'll understand it in a better way. So this is the broad classification of the types of foundations. We have different types also, like in deep foundations, we have well foundations and couple of others, but we don't need to focus on them. But let us just have it on a top surface or on a cream layer. The pile foundations and pier foundations are the two major subcategories of the deep foundations. And then in shallow foundations, we have five categories: isolated, wall, combined, cantilever, or strap footing, and then the raft foundation or mat foundation. So the categories which you have to remember is, when the BF value is greater than D, it's called as shallow foundation. When the BF value is less than D, then it's called as a deep foundation. Okay, right. So now let us understand the different types of shallow foundation. So here what I would like to let you know is, you let me know, I mean, you all must have completed your third year of engineering, so you all must have undergone the subject called the soil mechanics or geotechnical engineering. So you let me know, you can unmute and let me know. Let it be wrong, there is no problem. So let us have an interaction here. What is the type of foundation that I'm going to show you here? So this is the first type of foundation under the shallow category. Can anybody name what is the type of foundation here? No, it's not a foundation, it's a footing. What is the type of footing here? Can anybody unmute and answer this? It's okay if it goes wrong also, that's not a problem, but let us have an interaction also, more than one side conversation. Let us have a two-way conversation as well. Anybody, what is this type of footing called as? Anyone in the meeting? Can you unmute? Is it possible for you to unmute? Let me just check that. Yeah. It's better if you can unmute and tell, because I will not be able to access the chat box. So I think it would be better. Yeah, it's isolated foundation. That's correct. But I would suggest you to just unmute and let me know so that it will be better. Right. So the first type of foundation is isolated foundation or isolated footing. Now, what is meant by this isolated footing? Isolated footing is nothing but you will have one footing which is attached with one column. So this vertical member is called as column, and this is called as the footing slab. So when you have the footing which is with only one column, that is called as isolated footing. Okay, that is called as isolated footing. And the second one is, instead of texting, it would be better you can unmute and tell. Okay, so if you're not telling, it won't be, like, it will become one-way conversation, so that it won't be good. Anyways, fine. So this type of footing is called as a combined footing. Okay, this type of footing is called as combined footing. Now, what is this combined footing? Combined footing is nothing but you will have only one footing. Okay, you'll have only one footing, and on the top of footing, you will have more than one column. Okay, here I have just represented with two columns. Sometimes you might have three columns, sometimes you might have four columns also. Right? This is called as combined footing. So combined footing is nothing but you will have only one footing slab or one foundation slab, which is the bottom rectangle one, and then it is attached with more than one columns. So in this, usually the combined footing is used for two columns. So sometimes we also use it for three columns as well, but most of the times we'll use it for two columns only. That's called as combined footing. And the next one is called as isolated footing. So this is also an isolated footing, but the question here is, I have one isolated footing in one part of the site, and I have one more isolated footing which is available. They are close to each other. Now, these two isolated footings, I am going to combine it with a beam. Okay, I'm going to combine it with a beam. Can anybody tell what is this type of footing called as? What is this type of footing called as? This type of footing is called as strip footing. Okay, this type of footing is called as strip footing. What is a strip footing? So strip footing is nothing but you have two different isolated footings. Okay, you have two different isolated footings. These two isolated footings are connected with a beam. Okay, these two isolated footings are connected with a beam, and this beam is called as a strip beam. So some people will also call it as a strap beam. In any way you can call it as either strip beam or strap beam. So when you connect two isolated footings with a beam, that type of footing is called as a strip foundation, and that beam which is used to connect the two different isolated footings is called as a strip beam or strap beam. So you might have a question, why we need to use this kind of strip beam. So this we'll talk about when we are designing the strip foundations in the manual as well as in the CSI safe software. I'll be talking about the need for these ones. Here, my intention is to just show you what are the different types of shallow foundations. And the next one is called as, suppose let's say you have only one entire foundation slab. So this is the entire foundation slab. Now in this foundation slab, you will have the multiple columns. This is actually the plan view. That means when you see it from the top, this is how it looks like. So you have one footing or one foundation slab. On the top of one foundation slab, you will have many columns. All these white ones are the columns. So this is called as mat foundation or raft foundation. Okay, this is called as a raft or mat foundation. You can call it as mat foundation. So what does it mean by mat foundation? You will have only one foundation, and on the top of one foundation, you will have multiple columns, not just one column or not just two columns. All the columns of a structure will be available only on one foundation. So we'll talk about what is the need for these raft or mat foundations in the later cases. Okay, right. So that's how the different types of shallow foundations that we have. Okay, now let us look after the different shapes of the shallow foundations. So coming to the different shapes of the shallow foundations, the first one is called as square footing. Okay, this is an isolated footing. You can see clearly here. You have one column which is attached with one footing or one footing slab or foundation slab. So since this is in the square shape, it is called as square footing. So we also have the rectangular footings as well. Okay, isolated square footing, isolated rectangular footings. So I'll be talking about the design of both the isolated square and isolated rectangular footings also. But here it is an isolated square footing. And the next one is the stepped footing. So you can see here there is no only one footing slab. So you have two layers of the slabs are there. So this is the first layer, okay, the bigger one, and then the second layer. On the top of second layer, the column is being constructed. So this is called as a stepped footing. Okay, this is called as stepped footing. And the third one is called as sloped footing, or you can also call it as trapezoidal footing. So you can see the sides of the footings are actually not perfect square, they are actually the slopy area. Those are called as sloped footings. Okay, so isolated square footings, all these are isolated only. See, they are not combined. So one footing, one column. So here also one footing. So even though they are stepped footings, it is all considered as a one footing only. So one footing, one column. So here also one footing, one column. So these are all the types or shapes of shallow foundations: isolated square footing, isolated rectangular footing, and then stepped footing, that is isolated stepped footing, and isolated trapezoidal footing or isolated sloped footing. These are the different shapes of shallow foundations. We have a couple of others also. Let us show that. So this is actually the combined footing. Now here you can see there is only one foundation for two columns. So this is the first column and this is the second column. For these two columns, you have only one foundation. So you can see for all the structures or all the columns are like that only. They are all isolated. Sorry, they are all combined footings only. Okay, this is called as combined footings. So what does it mean by combined footings? Combined footings has only one foundation, okay, or one foundation slab, and on the top of it, two columns will be there. That's called as combined footings or combined foundations. And the next one is the strap footing. So what does it mean by strap footing? You have two individual isolated columns. Sorry, isolated footings. So this is the first isolated footing and this is the second isolated footing. So what they have done, they have connected these two isolated footings with a beam, and this is called as strap beam. You can see the reinforcement diagram here, and you can see the normal pictorial representation here. This is called as a strap footing. Okay, and then the other one is the raft or mat foundation. So what does it mean by raft or mat foundation? You will have only one complete foundation throughout the site. Okay, throughout the site area, you'll have only one foundation slab. And on the top of that foundation slab, you will lay multiple columns or you will construct multiple columns. You can see all the columns for this structure, they are all constructed on one foundation only. That's called as a raft or mat foundation. So this is one of the image that I have created by using a software called eTabs. Okay, there is a software called eTabs software. So I was taking the classes for one batch for eTabs. So there we have designed this kind of foundation, which is called as a raft or mat foundation. So raft or mat foundation is nothing but you will have only one foundation slab, and on the top of that foundation slab, you will have multiple columns that needs to be constructed. So these are the different shapes of the shallow foundations. And you can see here the isolated square, isolated stepped, and then the isolated sloped footing. These are the plan views. So the bottom images are the plan views. These are the front views or elevation view, you can say. Okay, and then the pile foundations. So pile foundations comes under the category of deep foundations. So you can see these are all the pile foundations. You can see a huge columns, not just a small columns, they are very huge columns. And these columns or these foundations are used when you are constructing especially the large bridges. Okay, long span bridges as well as the large bridges. In those cases you are going to use the pile foundations. And the second one is called as a pier foundations or Kaizen foundations. Pier foundations are nothing but you'll have huge number of pile columns or pile foundations at the top, at the bottom, and then you will construct a slab which is called as pile cap, and on the top of pile cap you can see the pier column or pier foundation. So this one you can observe mostly when you are going through highways, you will find out this one. Okay, you can observe this one. So maybe when you are going to your colleges, on your college routes, wherever you find the bridges in the highways, especially in the highways, you will find this kind of pier foundations. So what does it mean by pier foundations? You'll have the pile foundations at the bottom, and connecting to all these pile foundations you have a slab which is called as pile cap, and on the top of pile cap you have the pier. Okay, you have the pier, and on the top of pier you have the road, that is called as pier cap or pier cap. So on the top of it you will have the road or the pavement will be there. So this is called as pier foundations. Sorry. And the next one is called as a Kaizen foundations. So Kaizen foundations is something which is used especially in the oil rig platforms. So when they are rigging the oils from the deep down layers of the sea surfaces or ocean surfaces, then we are going to construct this Kaizen foundations. What does it mean by Kaizen foundations? So people will be constructing the closed surface structure which are called as Kaizen foundations, and hence whatever the water that is available around the sea, that water will not come into the foundation. So therefore it will be helpful to rig the oils from these kind of foundation. That's called as Kaizen foundations. Okay, those are also called as oil rig platforms. Okay, you can Google it, you will get many images of these ones, oil rig platforms. So these are the different types of shallow foundations and the deep foundations. This is one particular image where I was searching for one couple of things in YouTube. I mean, in the Google, I got this one where you can see the steel sections, the I beams. These are actually the I sections. So the I sections are being used as the foundations. Okay, I sections are being inserted as the columns in the foundation. So this maybe the purpose might be different, but this is the image that I would like to show you, since this is completely different from what we are discussing. It's a steel beams. Okay, they are not concrete beams, they are all steel beams, I section beams. Right. So now let us understand the difference between the shallow foundations and deep foundations. So we know the condition, what is meant by shallow foundation and deep foundation. So shallow foundations are also called as footings, and these are used for small buildings, and they are basically placed near the surface of the soil. Whereas the deep foundations are something which are placed near the soil surface, and also they will carry huge amount of loads. Okay, especially when you are constructing the bridges or when you are constructing the highways, you need deep foundations only. You cannot go with shallow foundations. They will not be able to carry huge amount of loads. That's the difference, simple difference. Let me talk about the failure modes in foundations. So there are basically three different failure modes that are available in the foundations. The first one is called as general shear failure. The second one is called as punching shear failure. And the last one is called as local shear failure. You might have come across, but let me just give a glimpse of these ones. The first one is called as a general shear failure, which is also called as sliding shear failure. Now, what happens or when this occurs? So, this type of a failure occurs when the soil that is below the foundation is unable to support the load. So, when you have the soil, let me show you the image. Right, you can see there is a column. Okay, there is a column here. From the column, there is a load that is coming down, and this is the foundation. You can consider this horizontal line as the foundation. Now, general shear failure or sliding shear failure, what it happens is when there is huge amount of load that is coming from the soil, that is coming from the superstructure, if this huge amount of load is not enough to bear this column, then the column will get settled or the column will get slided into the soil surface. That's called as sliding shear failure. Okay, you can see the column has got slided into the soil surface. That's called as a sliding shear failure or general shear failure. So that's the first type of failure mode, sliding shear failure or general shear failure. And then the second one is called as a punching shear failure. So this occurs basically when you have the huge amount of concentrated loads that are coming from the superstructure. Suppose if you take this one, there is a column which is attached with the foundation. So there is a load that is coming, which is Q kilonewtons of load that is coming onto the structure. So when this Q kilonewtons of load, which is a point load, if this point load is acting directly on the surface of the column or directly on the surface of the foundation, whichever part that concentrated load is acting, that entire part will get sheared into the or will get punched into the soil surface. That's called as punching shear failure. All of a sudden, if you punch your, let's say you are punching your hand into the soil. Now what will happen? Wherever you are going to punch the sand at that particular portion, you can see the small impression. So that's called as punching shear failure. Okay, you can see the failure pattern here also. So the failure pattern will be the sides of the column, whatever the sides that is there, this sides, it will experience the shear failure. Usually all types of foundations will experience the shear failure only. Okay, they will not experience any other types, but depending upon the type of load. Okay, what type of shear failure? General shear failure or punching shear failure or local shear failure. And the next one is called as local shear failure. This also again occurs at the soil foundation only when it is not able to develop the shear stresses at the support. I'll show you the image. You can see this is a column which is coming down, and at the surface edges, okay, at the surface edges of the foundation, if it is unable to carry the load, then such kind of failure is called as a local shear failure. Now, in local shear failure, what happens is on the top surface, you will find a small impression that's called as upheaval. Okay, or you can also call it as a heaving of the soil. The soil surface will have a little bulge on the surface. That's called as upheaval. So these are the three different failure modes in foundation: local shear failure, general shear failure, and the punching shear failure. These three things are very much important when we are designing. That's why we are discussing all these categories over a period of time. Okay, right. So this is the summary of the entire failure modes of the foundation: global, local, and the punching shear failure. Okay, so that is all about this particular session. In the next session, what we will do is I will be talking about couple of things that are related to what are the different types of stresses that are developed in a soil mass, and then I'll be talking about the punching shear failure, local shear failure, and global shear failure on a large scale, because those are very much important before we go and design. So tomorrow's class, we'll be talking about couple of extensions things for this particular session. Along with that, if time permits, I'll also be discussing about how to design an isolated rectangular footing. Okay, I'll talk about that one. Right. So that's from my end for this particular session. If you have any doubts, you can unmute and ask the doubts. Thank you.